Hey, today we're going to begin some topics that will be covered on our second exam. And these topics are found in Chapter 3. So, Chapter 3 discusses the periodic table, probably the most important tool that we use as chemists because it gives us lots of information about all the elements that we have in our universe. And in the first few sections, we're simply going to discuss periodic properties and a little bit about the history of the periodic table. And in our next section, we're going to be discussing electron configurations. And these will bring into light the quantum numbers that we learned earlier in Chapter 2. And finally, we're going to be discussing maybe the most important feature of the periodic table. And that's how the periodic table gives us a way to predict properties of elements based upon their position in the periodic table. And that's what we call a periodic trend. So before we get into any detail about the periodic table, we need to define what a periodic property is. So simply stated, a periodic property is a property of an element. And in your textbook, the author discusses densities of elements and how the densities of elements can be predicted based upon an element's position in the periodic table. So this is what a periodic property is. It tells us that we can understand a little bit about the property of an element and how they trend, how they may change based upon a comparison of elements in the periodic table. And that's simply Chapter 3.1, simply discussing what periodic properties are. Chapter 3.2, we begin a lot of detail of some of the material that we're going to be discussing. And in this section, we're going to define what the periodic law is. And we'll discuss a famous scientist, a chemist that's responsible for recognizing the periodic law. And then we're going to be discussing our periodic table, how it's organized. It looks confusing, but we want to get a better understanding of what all these symbols mean and what these numbers mean and how these elements are positioned in the periodic table. And then we're going to begin and discuss how we classify the regions of our periodic table and learn a little bit about the elements that are in these different groups and help to understand how we can navigate through the periodic table. So let's just move back in time a little bit, a little history lesson. Early to mid 1800s. And remember, this is before the discovery of subatomic particles. Remember, the first person that was studying those was J.J. Thomson, 1890s. So earlier than that, scientists did recognize that certain properties of elements occur in a repetitive fashion. And it was in 1869 that a Russian chemist, his name was Dmitry Mendeleev, he organized the known elements at that time according to their mass. And he discovered that when elements are arranged according to their mass, in terms of increasing mass, certain sets of properties reoccur periodically. And this is the essence of what we call the periodic law. And this led to the development of the early periodic table. What was really important about Mendeleev's insight was that he was able to see that there were elements that weren't known in his time that he predicted would be found later in time. And they did prove to be true. So his predictive nature using his periodic table, really important. And it was a major breakthrough in science at that time. So to really use the periodic table, we need to know how it's structured and what all these numbers mean. So let's look first of all at these numbers on the side of the periodic table. 1, 2, 3. Now these are essentially horizontal rows. We go from left to right. And the numbers here are called periods. We have period 1, period 2, period 3, period 4, period 5, and so forth. we're going to learn more about what these periods are and what these numbers mean when we start to assign electron configurations. This will come into better understanding a little bit later. What we do need to recognize is that going across a period, we get a lot of variation in the chemical properties associated with the elements when we go from left to right. So that's real important. Now, another important feature are these columns that go from top to bottom, and there's a lot of different numbers. So if you look at these, this is where a lot of times it's like, well, what numbering system? What did these numbers mean? These numbers tell us a little bit something about what we call the groups of elements. And there's different numbering methods. If people are familiar with Roman numerals, we have Roman numeral 1A, 2A, 3A, 4A, and so forth. The IUPAC, which is the International Union of Pure and Applied Chemists, they like the 1 to 18. What we're going to use is another method that's listed in your textbook, and I like this one. It's just using our normal numbers, 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A. Now, what the A tells us as chemists that these are what we call our main or representative group elements. And they're the ones we're going to be focusing on a lot in this course. And we will spend some time on these elements that sit in the middle of the periodic table. They have a B associated with it. These are called our transition elements. And we will briefly discuss those as we move through the course. But we will spend a lot of time, especially when we start to make predictions using the periodic table for our main group or our representative elements. So the first way we're going to treat the periodic table is we're going to learn how we classify elements very generally, and then we're going to get into the specifics of how we classify them by giving these groups particular names. So, and again, we're going to look at the main group elements. Now, the periodic table I have listed on my PowerPoint has a color coding associated with it. Normally, we don't get that. Normally, it's a black and white. There might be some different colors of the letters, which tells us a little bit something about the physical state of that particular element. But we do need to understand the positions of these elements on the periodic table. And the first we're going to look at, and again, we're looking at main group elements, are what we call nonmetals. Okay, nonmetals are the main group elements as we face the periodic table. These sit on the right-hand side of our periodic table. Now, nonmetals have specific properties associated with them, and we can look at these elements that are nonmetals, and we would show that they have these types of properties. Nonmetals are poor conductors. If you know a little bit about electricity, that would tell us that these are actually good insulators. Most of our nonmetals are gases or liquids. So this is where the color coding comes in. Green over here, those are green, those are gases. Blue are the liquids. We do get a few of them that are solid at room temperature. And in chemical bonding, what we find is that our nonmetals typically gain electrons, and that's going to be an important feature of nonmetals as we move through a little more discussion on chemical reactivity. Metals are different than nonmetals. And if we look at the periodic table in our main group elements, these are found on the left-hand side of our periodic table. Metals have certain properties. They are good conductors of heat and electricity, ductile and malleable. This means they can be pounded into sheets or drawn into wires. Most of them are solids. Notice most of those are black. Only a few of them are liquids. And one actual exception to our metals. Hydrogen is an exception. It's actually a non-metal. We're going to learn that hydrogen has a lot of exceptions to certain rules, and we'll learn more about the unique nature of hydrogen as we get into later discussions. In chemical bonding, what we're going to learn is that metals tend to lose electrons. And remember, the exchange of electrons are really important. Exchanging or sharing of electrons, as we'll learn a little bit later, really important features of chemical reactivity. So another important class on our periodic table are what we call metalloids. Let's look at, and these are also known as semiconductors. Metalloids sit upon a stepwise feature that sort of separate the nonmetals from our metals. And typically it has a feature that, again, is usually not listed, but it has a step feature here down the center of the periodic, or over here on this side of the periodic table. This is where we find our metalloids. I'm sorry, guys, like this. So this region that separates our nonmetals from our metals, these are elements that are what we call metalloids or semiconductors. There's only a few of them that you need to know. These include boron, that's a metalloid, aluminum, silicon, Ge is germanium, As is arsenic, we have Sb is antimony, tellurium. We also have astatine over here. Those are some of our important metalloids or semiconductors. Now, as we said, they have properties that are somewhere in between a metal and a non-metal. They're useful in the computer industry, and probably the most familiar that we may know about is silicon. Silicon is used a lot in computer products, and there's actually a region in California called Silicon Valley because there's a lot of computer companies there. So we actually can recognize a general trend based upon metal and non-metal characteristics. And we're going to learn more about trends as we move through this chapter. The first trend, and this is what a periodic trend is, a periodic trend is looking at properties of elements either going from left to right across a periodic table or from top to bottom down a group. What we recognize is that a periodic trend here in metal versus non-metallic characteristics, metallic character is going to decrease as we move from left to right across a period. And that's our first periodic trend. We're going to be discussing several more later in chapter 3.6 and beyond. Now, that was just a real general way of how we classify elements. We also have a more specific way by using names for groups. And down a group, we're going to find that the elements that sit in a particular group share very similar chemical properties. And some of these are given names. And we're going to go through some of the names of the groups that you need to know on your second exam. Let's look at group 1A. So this is group 1A. And again, hydrogen, we're not going to consider part of group 1A. It's kind of unique. We're thinking of these elements from lithium, sodium, potassium, rubidium, cesium, and francium. Group 1A elements have a name. That group 1A are called alkali metals. They share similar chemical properties and reactivities that we're going to learn about more in this course when we get a little bit later. Now, group 2A, these are also metals that share similar properties in that particular group, and we give these a name also. Group 2A are called alkaline earth metals. These include beryllium, magnesium, calcium, strontium, barium, and radium. So those are our group 2A alkaline earth metals. We do have two other groups that I want you to know. Group 7A, down here on the other end of the periodic table, group 7A are called halogens. Halogens include fluorine, chlorine, bromine, iodine, acetine. Those are our halogens. Group 8A are called our noble or inert gases. And we're going to learn that they're called noble or inert gases because they're not very chemically reactive. These include helium, neon, argon, krypton, xenon, radon. So you need to go through and study your periodic table and start to recognize the groups that we have and the names of the elements within those groups that we've just mentioned. So let's go over a couple of examples of how to navigate the periodic table. So let's look for the symbol for the element found in period 5, group 5A. So period 5, now that's period 5 goes across here. And then we're going to look for group 5A. That's 1A, 2A, 3A, 4A, 5A. SB is in period 5, group 5A, and that's antimony. Period 2, group 4A. Here's period 2, and we're going to go to group 4A. 1A, 2A, 3A, 4A. That would be C, which is carbon. Period 6, group 2A. Here's period 6, 1A, 2A, that's BA, that's barium. So which of those elements is a metalloid? Well, that would have been the antimony is a metalloid. Which one was an alkaline earth metal? That would be barium right here. So which of the following we're going to list is a halogen? Now I gave you several choices. The first one was S. S is sulfur. Sulfur is in group 6A. It's not a halogen. Remember, halogens are found in group 7A. Calcium, Ca. Calcium is over here. Calcium is an alkaline earth metal, not a halogen. Fe. Fe sits here. Iron is actually what we call a transition metal that we're going to learn more about in our next lecture. Cl. There's Cl right there. Chlorine. Chlorine sits in group 7A. It's a halogen, and that's the choice that we would make for that particular answer for that question. Rb is rubidium, and rubidium is right here. Rubidium is an alkali metal. So that's just a general idea of how the periodic table is structured and how we list elements according to group name and specifically, and how we classify them very generally as being either a metal, a non-metal, or a metalloid. We'll continue in chapter 3.3 for Friday's lecture. Thank you very much. Have a nice day. Periodic table. Yay. Okay, that's the period.